Hello everyone, welcome to iQuanta. In LRDI series, we are going to discuss CAT 2022 slot 2 second set today. It says every day a widget supplier supplies widgets from warehouse W, this is warehouse W, to 4 locations Ahmednagar, Vikrampur, Chitrachak and Deccan Park. These are denoted as A, B, C and D. Now it says the daily demand for widgets in each location is uncertain and independent of each other. Demands and corresponding probability values in parentheses are given against each location A, B, C, D. These are the value given as per demand and their probability. Now it says, for example, there is a 40% chance that a demand in Ahmednagar will be 50 units. This 50 and this 40. So demand in Ahmednagar is 50 units. The probability of that happening is 40%. And similarly, there is a chance 60% that demand will be 70 units. 60% chance of demand 70 units in Ahmednagar. Let's say the line in the figure connecting the locations and warehouse represent two-way routes connecting those places with the distances in kilometers shown beside the line. So with all the lines, there are some values given. These are nothing but the distances between two particular locations. Now it says the distances in both directions along a road are equal. For example, the road from Ahmednagar to Vikrampur and the road from Vikrampur to Ahmednagar are both 6 kilometers. Ahmednagar to Vikrampur or Vikrampur to Ahmednagar, the distance is 6 kilometers. Next, it says every day the supplier gets the information about the demand values of the 4 locations and creates the travel route that starts from the warehouse and ends at a location after visiting all the locations exactly once. So we cannot go twice on any of these locations A, B, C, D. While making the route plan, the supplier goes to the locations in decreasing order of demand. Decreasing order of demand means we can never go to B first and then C, because in C demand is always greater than B. Now, if there is a tie for the choice of next location, the supplier will go to the location closest to the current location. So let's say if there is a demand of 70 units at A, there is also a demand of 70 units at C, then the supplier will go to A first because the distance from warehouse to A is 5 km, while distance to C from warehouse is 12 km. So the minimum distance is W to A. While creating the route, the supplier can either follow the direct path if available from one location to another, or can take the path via the warehouse. So from C to D, a person can go from direct path like C to D, or the person can go from C to W, then W to D. That depends. If both paths are available, direct and via warehouse, the supplier will choose the path with the minimum distance. Like in case of C to D, we will choose direct path. The supplier will choose direct path because via warehouse the distance is bigger. But in case of C to A, the direct distance is 8 km, while via warehouse the distance is 7 km. So if the supplier is choosing to go from A to D, he won't choose the direct path, he will choose via W and vice versa. Now, the first question, it says if the last location visited is Ahmednagar, then what is the total distance covered in the route? So Ahmednagar is the last location. So we are going to start from W, then first location, then second location, then third location, and then comes Ahmednagar. Now what we can say about Ahmednagar? If Ahmednagar is at the last location, it cannot be 70. If it's 70, then all the values, all the demands must be greater than 70, while we don't see demands greater than 70 at D or at B. The only demand which is greater than 70 is C. So in that case, the demand at A must be exactly 50 units, right? And at C, the demand could be 70 or 100, right? So first location must be C because it's greater than, both of these values are greater than these two values and these two values. So at demand at C could be 70 or 100. Then the next value that we choose, these two values must be greater than equal to 50. So this value must be greater than equal to 50. It could be 50 or it could be 60. But if I choose 60 here, then this value must be greater than equal to 60. It's not possible. If I put B here, and with B, if I choose 60, it's not possible. So this value cannot be 60. There were two values which is greater than equal to 60, which is one of them is 50, one of them is 60. If you choose 60 here, you cannot put anything greater than 60 here. We know that the demands are being supplied in decreasing order. So if 60 cannot be put here, we can put only 50 here. So this will be 50 and the location will be D, and this value must be 60 and the location will be B. Next is, what is the total distance covered? So total distance covered from W to C, it's 12 kilometer. From C to B, it's 4 kilometer direct route. From B to D, 10 plus 2, it will be 12 kilometer. From D to A, we will take via warehouse, which is 7 kilometer. So total it becomes 19 plus 16, which is 35 kilometer. So answer should have been 35 kilometer, but this is wrong. This is the answer that CAT has given while evaluation, okay, but this is wrong because if you check, we know that if demands are same, from B to D, demand is 50, from D to A, demand is 50. But if you check, from B to D, the distance is 12, and from B to A distance is 6. So we must go to A first and then D. So can we say A cannot be at the last location? Cannot be. It's not possible. So basically, this is a wrong question. This was a wrong question, and this question was revoked later and it was not considered for marking. So let's leave it here. Move to the next question. It says, if total number of visits delivered in a day is 250 units, then what is the total distance covered in the route in kilometer? So 250 units. For each location, we have two different values for total number of units. So how do we find 250? It could be very tedious work. If you want to try each possibility, it will be 2 into 2 into 2 into 2, which is 16 possibilities. But in these kind of situation, you should always try with maximum or minimum values. So what is the maximum value that we get? So maximum demand will be 100 plus, for A it will be 70, for D it will be 50, and for B it will be 60. And if you add all this, this is 280 units. What do we want? We want 250 units. Now, if you check the minimum values, so instead of 100, we can take 70. Instead of 70, we can take 50. Instead of 50, we can take 30. Instead of 60, we can take 40. So this will be equal to 120 plus 70, 190 units. Now what we can do? We can decrease this value by 30. If you decrease this value by 30 only and keep the remaining as it is, we get 250 units. If you decrease this value by 20 and keep the remaining same, then you get 260 units, not 250 units. So the difference is 20 in rest of the three cases. If you decrease one or two of these or three of these, the difference from maximum will be 20 or 40 or 60, which won't get us 250 units. How do we get 250 units? Only when we take the difference of 30, 250 and 280. Difference is 30. So the only value we require is taking this as 70 and keep the remaining as it is. This is how we get 250 units. Now we know the demand that we are taking everywhere. Like in case of A, we are going to take 70. In case of C, we are getting 70 units. In case of A, again, we are getting 70 units. In case of this one, D, we are taking 30 units. In case of B, we are taking 40. Now, we just need to figure out the route, right? What route we need to take. So, in C and A, both have 70 units of demand, but the distance is minimum in case of A. So, we are going to start from W. We are going to go to A. Then we are going to go to C. And then we are left with 50 and 60. So, first we are going to go maximum demand, which is B. So, we are going to B, and then at the end we are going to D. Now, what's the distance, total distance covered? From W to A, it's 5 units. From A to C, it's 12 plus 5, 17 units. From C to B, it's 4 units. And from B to D, it will be 12 units. If we add all these values, 12 plus 16, 38 kilometer is our answer for second question. Third question, it says, what is the chance that the total number of widgets delivered in a day is 260 units and the route ends at Vikrampur? The route ends at Vikrampur. So, demands at Vikrampur is 40 or 30. So, first we are going to start with warehouse. Then we can go to A or we can go to C, right? Total demand is 260 units. We already know that maximum demand is 100 plus 70 plus 60 plus 50, which is equal to 280 units. How do we get 260 units of demand? So, we need to decrease either of these as 20. We can take 100 plus 50 plus 60 plus 50. This will give us 260. Or we can take 100 plus, keep this as it is, 40 plus 50. This is 260. Or we can take 100 plus, keep this as it is, keep this as it is, and take this as 30. Then we get 260. So these three are possible. First case we won't take, but we need to consider these three cases, right? So what is the chance that total number of widgets delivered in a day is 260 units? These are the possibility, but we need to check which one of these is feasible. So we are definitely going to start with C, right? Because 100 units demand. So we are going to start with W, then we are going to C. After C, in this first case, after C, there is a 50 units of demand at A. So these are basically C, then A, then 60 and 40, this is B, and then D. Okay. So if we consider this first case, we are going to go from warehouse to C and then C to B. From B to, we can choose to go to A or we can choose to go to A. D. From B to A, distance is 6. From B to D, distance is 12. So definitely we are going to choose A and then we are going to choose D. Now, total demand is 260, right? This is one of the case. If we consider this one, let's check out this one. What will happen here? So we are going to start from W, then we are going to C, then after C we are going to A, and then 40 or 50, so we are going to go to D, and we are going to go to B. So it says the route ends at B. We can discard the first case. We must choose this one, or if it is possible in this case, let's see, we are going to go to W, then we are going to go to C, then A, and from A to B, and B to D. Again, this case is not possible. So we are going to consider only this case, warehouse to C, C to A to D, and D to B, because D, the route ends at B. So what are the chances? Demand is 100 at C, chance is 0.7. And at A, demand is 70, chances is 0.6. At D, demand is 50. So chances are at B. At B, demand is 40, right? Demand is 40. So from A to D, again, the chance of getting D as 50, this will be 0.6, and then chance at B getting 40 will be 30%, which is 0.3. If you multiply out this, 7 into 6, 42, into 6 into 3, 18, we get 756, which is 0.0756. In percentage, this will be 7.56%, which is option C. So we got 3 cases where total units delivered will be 260, but in only one case we got the route ends at Vikrampur, and so the probability, the chance of delivering 260 units will be 7.56. Fourth question, it says if the first location visited from the warehouse to Ahmednagar, then what is the chance that the total distance covered in the route is 40 km? So see, if you are choosing Ahmednagar as the first location, it cannot be 50, it can only be 70, and after it must be C, and it cannot be 100 because the demands must be in decreasing order. So we can say we are starting with W. From W, we are going to A, then we are going to C. Now we have 2 options. We can go to either B or we can go to D. So let's consider both the possibility from B to D, or we can choose warehouse to A to C, C to D, and D to B. So it's a, what is the chance that the total distance covered in the route is 40 km? So where do we get 40 km? W to A, it's 5 km. A to C, it will be 17 km. C to B is 4 km, and B to D, it's 12 km. So 16 plus 22, this becomes 38 km, which we should not choose because total distance covered is 40 km. So W to A, again 5. W to A to C is fixed always. As soon as it says in the question that first location is Ahmednagar, second location is C fixed. So we don't need to worry about this. We need to worry about this or this. So A to C, the distance is 17. C to D, the distance is 6. And D to B, the distance is 12. So 18 plus 22, the distance is 40 kilometers. So there are 2 possibilities. We can go to 38 kilometer or 40 kilometer. But question is about what is the chance that the total distance covered is 40. What is the chance of this happening? We already know that W to A to C is certain. So we need to find the chance of happening one of these 2 routes or this route only. So at D, then B. So first we need to figure out what will be the demands. So at W to A to C, so this must be demand must be 70 here, demand must be 70 here, then D, then B. If I take 30 at D, it's not possible because at B both the values should be lower than 30 or equal to 30. So this must be 50. If this is 50, then this must be 40. Chance of demand of 50 units at D is 60%, which is 0.6, and the chance that demand is 40 units at B is 30%, which is 0.3. This gives us 0.18, or in percentage this is 18%. So option D is correct here. Now last question, it says if Ahmednagar is not the first location to be visited in a route. Now it says Ahmednagar is not the first location to be visited in a route. It cannot be the last location to be visited in the route, as we have seen in the first question, which was wrong because of only this. So the position of Ahmednagar must be second or third, right? So if Ahmednagar is not the first location to be visited in a route, then the total route distance is 29 kilometer, and the total route distance is 29 kilometer. Then which of the following is a possible number of visits delivered on that day? So if Ahmednagar is not the first location, so we must start with, if Ahmednagar is not the first location, means we must start with C. Now, Ahmednagar must be at second or third position. So there will be two possibilities. We can go to Ahmednagar first, then we can go to B, then we can go to D, or W to C, then we can go to A, D, then B. And if you put Ahmednagar at third position, like this, so B, then, so this value, we are putting Ahmednagar at third position, so we must put A here. So there will be two possibilities, B to D or D and B at second and fourth position respectively. These are the possible cases that we get in this question when Ahmednagar is not at the first position. Now we need to find out the distance. When the distance is 29 kilometer, in which case we get the distance as 29 kilometer. W to C, 12 kilometers. This distance is 12. C to A, 17. This is already 29. So we can cancel this out. W to C, C to A, again we can cancel this out. W to C, 12. C to B, C to B is 17. C to B is 4 kilometer. B to A is 6 kilometer, and A to D is 7 kilometer. So 16 plus 13, this is exactly 29 kilometer. Now let's check out this one. W to C, 12 kilometer. C to D is 6 kilometer. D to A is 7 kilometer, and A to B is 6 kilometer. So 18 plus 13, this is 31. Again, we can cancel this out. Now, what are the possibilities of demands in these locations? So as we are starting with C, it could be either 100 or 70. But A is coming after B. The demand at B is 40 or 60. The demand at A is 50 or 70. We cannot take 40 here, because then Ahmednagar won't be after D. Both the demands at Ahmednagar, 50 or 70, would be greater than 40. So we must take 60 as a demand at B. Then from B to A, the demand at A, it cannot be 70. We must take 50 here. From A to D, this demand could be either 50 or 30. Right? Because as you can see, the distance is also bigger. Even if you take 50 from A to D, B to A, the distance from B to D is 12. So we must choose D after A. So these are the possibility. What would be the sum if we take the minimum? So 30 plus 50, 80 plus 60, 140 plus 70 is 210, right? Which is one of the values in the options. You can also take 30 plus 50 plus 60 plus 100, which will become 240. Or we can take 50 plus 50, 100 plus 60, 160 plus 70, which is 230. Or 30 plus 50, 80 plus 60, 140 plus 100, which is equal to, again, 250, I guess. We have taken 210 as minimum values, 70, 60, 130, 180, 210. Then we get 30 plus 50, 80, 1. Yeah, this is 240, I guess. Again. So 4 different values. Let me check if this is, we are getting 250 as. So 100 plus 60, 160 plus 100, 260. So one value that is missing is 260. So there are 4 possibilities of number of visits delivered on that day. In options, if you check, there is only one of these values given, which is 210 option A. So with this, we are done with this set. Definitely not an easy set. Lots of cases to consider and a little bit time taking. With first question getting wrong, it could be a little bit of like panic situation that you are understanding the question but you are not able to solve it, or you are getting wrong answers. Ahmednagar is not possible at the last location. So definitely not a good set to attempt at your like first set in your exam. Okay, but rest of the questions are very good, very good, and you should choose your sets wisely. That's why it's very important that you should do a proper scanning. Take your 5 to 6 minutes to scan all the sets and start with the easiest one where you do not land on sets like this. So I hope you understood the solution, and if you want to check more videos like this, you can go to iQuanta YouTube channel and check those videos. Thank you.